Okay, dear students, let us see how to do this question. What is true about the acceleration of particle that is oscillating with simple harmonic motion? So there is an object of mass m, let us say, and it is undergoing simple harmonic motion. And the question that is asked to us is what is true about the acceleration of the particle? Let us see. It is in the opposite direction to its velocity. Well, not always. Sometimes yes, but sometimes no. I show you how. Like whenever we are talking about the SHM, it's always easy if we try to imagine a spring mass system. So this is the mean position, and these are the two extreme positions. Let us say this and this. So this is extreme position, and this is another extreme. Now, when the mass is moving towards this side, like it is moving from the mean position to the extreme position, it is going like away. So at that time, the velocity vector is towards right, but the acceleration vector is towards left. So they are in the opposite direction. Now it says that it is in the opposite direction to its velocity. Well, it is correct for this duration. But what happens if, like let us say, the body is moving from extreme position to the mean position back again? So now the velocity vector will be like this, and the same direction will be for the acceleration. So acceleration and velocity are having the same direction when they are moving from extreme position to the mean position. It means sometime it is right and sometime it is wrong. So A is not always correct. B, it is decreasing when the potential energy is increasing. Now, when the potential energy is increasing, so why the potential energy will be increasing? If the displacement is increasing, like if the body is moving away from the mean position, the potential energy will be increasing. So it means that it will be the earlier case that the body is now moving away from the mean position to the extreme position. So if that happens, the potential energy increases. So it is saying that the acceleration is decreasing. No. Because if the potential energy is increasing, it means there is more displacement. Like potential energy is equal to half kx square. If this is increasing, it means x is increasing. And it only means that the force is equal to kx, so it is also increasing. So it means that acceleration should also be increasing. Ma is equal to kx. So acceleration will be increasing, so B is also wrong. Let us go to C. It is proportional to the frequency of the oscillation. Well, the acceleration has nothing to do with the frequency anyways, so it's definitely wrong. So let us talk about D. It is at a minimum when the velocity is at maximum. So there is a concept here, and you should be able to understand this properly. Like what happens is that when we are at mean position, let us say, the displacement is zero at mean position, but the velocity is maximum because it's moving like at a very fast speed. It is moving now, so velocity becomes maximum. And what is the acceleration? Zero again. Why? Because the force is zero. So when the force becomes zero, the acceleration will definitely come out to be zero. So it means that acceleration is zero here at the mean position, which is the minimum value. Now let us talk about the extreme position. At extreme, the displacement becomes max, the velocity becomes zero. It stops at the extreme position, okay, because it was going towards left. It stops and then it starts moving towards left, so it will stop for a moment. Velocity will become zero, but the acceleration will also be maximum, and it will be towards the center. Why? Because the restoring force is now maximum. So x is maximum, force is maximum, and hence the acceleration is maximum. So it only means that yes, the acceleration is minimum when the velocity is maximum. So velocity is maximum here and acceleration is minimum at the mean position, which is zero. And so the acceleration is minimum. So yes, the answer will be D. So my dear students, this is the explanation for this question. If you have any problem with the explanation even now, please do mention in the comment section. All the best. Bye.